Okay, picture this for a second. You're out walking, maybe along an old stream bed somewhere like Montana. It feels ancient.
Hmm.
And then you spot them, just these scattered bones.
It's lying there.
Yeah,
And that image, that chance find, it's really the start of the story we're digging into today.
exactly. We're doing a deep dive into Avaceratops.
Uh-huh. A plant-eating dinosaur, late Cretaceous. Not huge, maybe, but really interesting in terms of where it fits.
Yeah, and our info, it's coming straight from the science, like
Yep.
Peter Dodson's original paper from '86, plus all the research since then.
Solid stuff.
So our mission today is to really get under the hood of Avaceratops, understand what makes it tick,
How it was found, its place in the family tree.
what it tells us about its world, basically everything you need to know about this pretty cool little dinosaur. So where do we kick things off with the discovery?
Okay, so the story starts back in 1981. And it was this guy, Eddie Cole, who actually found the first pieces. This was in the Judith River Formation in Montana, specifically on the Careless Creek Ranch.
Oh, wow. So not like a big planned university dig initially.
No, not at all. The ranch was owned by Arthur J. Lammers. It was more of a, well, a lucky find on private land.
That really paints a picture, doesn't it? Just
That-
stumbling across prehistory. What shape were the bones in? Like a whole skeleton?
No, far from it. They were all scattered. Kind of jumbled up. The best guess is the animal died upstream somewhere, got washed down by a river, and then, the bits and pieces got buried in a sandbar eventually.
A bit of a rough ending for the dinosaur itself.
Yeah, but lucky for us, I suppose. That burial is what preserved it.
Right. So how do we get from scattered bones on a ranch to a whole new dinosaur species name?
Well, Eddie Cole actually owned a fossil shop. And he had these bones on display, and that's where the paleontologist Peter Dodson first saw them in late 1981. That got his attention.
Okay.
Then the next summer, Dodson visited the ranch with Cole and found even more material himself. But the really expensive digging, that started in 1984 with Anthony Fiorillo leading the excavation efforts, like peeling back layers, finding more clues.
So it built up over a few years then.
Exactly. And then in 1986, Dodson formally described it. He named it Avaceratops lammersi.
Avaceratops lammersi.
And here's a really interesting bit. It was actually the first new ceratopsid genus, horned dinosaur, named since Pachyrhinosaurus way back in 1950.
50. Wow, 1950. That's a long gap.
It really is. It shows you just how significant this find was at the time. It kind of broke a dry spell.
Definitely puts it in context. And the name itself, Avaceratops lammersi, there's a story there too, right?
Yeah, there is. Avaceratops honors Ava Cole, Eddie's wife,
Oh.
and Lammercy, that's the Lammers family, who owned the ranch where it all happened.
That's nice. A connection to the people involved.
It is a way to acknowledge their part in the discovery.
But I seem to recall there was a little discussion about the specific ending of the name, a bit of a debate.
Ah, yes, you're right. In 1990, George Olszewski, another paleontologist, suggested it should maybe be A. lammersorum.
Lammers hortolanimum, why the change?
Well, his thinking was based on Latin grammar. Since Lammers is a family name, he argued the plural genitive ending, or mersum, would be technically more correct, referencing the whole family.
Okay, plural for the family versus, what did Dodson say?
Dodson basically said, well, hang on, the singular I ending can also refer to the family name treated as a single unit, a collective. It's one of those fine points of scientific naming rules, like how you'd refer to the Smith property versus listing all the Smiths.
Huh. Interesting how even scientific names can have these little nuances. Was that the only naming suggestion that popped up?
No, actually. Same year, 1990, Thomas Lehman proposed maybe it should be Monoclonius lammersi, reclassifying it.
Monoclonio.
Yeah, but that idea didn't really catch on with other scientists. So Avaceratops lammersi is the name that's stuck and is still used today.
Got it. So discovery, name, a bit of academic back and forth. Let's talk about the actual animal. What did it look like? How big are we talking?
Right. So the main specimen, the one everything is based on, it's called the holotype specimen, ANSP 800. And it's not complete, but it's pretty good. We've got the lower part of the skull, the left lower jaw, some vertebrae, the shoulder girdle, most of the limbs. Quite a lot to work with.
Okay. And based on that first specimen, ANSP 800, what was the initial size guess?
Dodson, in his 86 paper, he reckoned it was probably a nearly mature animal. And he estimated its length at about 2.3 meters. So roughly 7.5 feet.
7.5 feet. That's like pretty small for a horned dinosaur, isn't it?
Yeah, definitely on the smaller end of the scale for ceratopsids.
But then
Well,
things got a bit more complicated, didn't they? There was another skull found later.
exactly. That threw a bit of a wrench in the works, size-wise. In 1999, Paul Pinkowski and Dodson described a second skull, MOR 692. And this one was significantly bigger than the original skull material. Based on this bigger skull, this suggested a total length closer to 4.2 meters, about 14 feet.
Whoa, hold on. From 7.5 feet to 14 feet. That's a massive difference.
It really is, almost double. It immediately raised questions,
Mm.
Is the first one just a juvenile? Or is there more variation? Or is MOR 692 even a Avaceratops? That's still debated.
Right. That complicates the picture. Okay, what about horns? I remember seeing reconstructions with a nose horn.
Yeah, the early reconstruction, the one in Philadelphia, definitely had a nasal horn put on it. But the current thinking among most paleontologists is that Avaceratops probably didn't have much of a nose horn, if any. Maybe just a low bump.
Okay, so scratch the big nose horn image. What about the brow horns over the eyes?
Well, that second larger skull, MOR 692, gives us a clue there. It seems to show longer brow horn cores the bony part inside the horn, maybe around 25 centimeters, so almost 10 inches long.
So if MR692 is a Avaceratops, it had decent brow horns.
Potentially, yes.
Yeah.
More substantial than you might guess from the first smaller specimen. But again, that if is important. The jury's still kind of out on whether MOR 692 belongs to this genus.
It really shows how tricky piecing these animals together can be, especially with incomplete fossils. What about the frill, that big shield at the back? Was it distinctive?
Yes, the frill had some interesting features. The side bones, the squamosals, are quite large. And they have this smooth, continuous curve along the edge, not stepped or scalloped like you see in some others.
Shillith curve, okay.
And there's also this sort of raised bar or ridge running across the squamosal, kind of dividing it. In later, more derived species, the top part tends to be bigger.
Interesting detail. And the back part of the frill, the parietals. Any holes, or was it solid?
Good question. The parietals don't seem to have that dip in the middle that some ceratopsians have. And crucially, they seem to have been solid. No big openings or fenestrae like you see in, say, Centrosaurus, but similar to Triceratops in that way.
A solid frill, like Triceratops.
Pretty much, yeah. A solid shield. Though we have to add a little caveat, the original skull is damaged right there. So there's a tiny, tiny chance there could have been a very small opening. But solid is the most likely interpretation.
Okay, so solid frill, maybe decent brow horns, probably no big nose horn, and a size that's still a bit debated. Let's zoom out again. Where does Avaceratops fit in the big dinosaur family tree?
Well, Dodson originally placed it firmly within the Ceratopsidae family. That's the main horned dinosaur group. And that family is part of the larger group, Ceratopsia, literally horned faces, which includes all those beaked plant-eating dinosaurs, mostly from the Cretaceous of North America and Asia.
Right, the broad strokes. But getting more specific, figuring out its closest cousins, that was harder.
It was, yeah. For a while, it was tricky. A big reason is that the holotype, ANSP 5800, is thought to be a juvenile or maybe a subadult. And younger animals can sometimes keep more primitive or ancestral features.
Ah, so comparing a kid dinosaur to adult dinosaurs messes up the analysis.
They can, yeah. Those clistic analyses rely on shared derivative features. If you're comparing juvenile features of one to adult features of others, you might get a misleading result. So sometimes Avaceratops was just left out of those studies to avoid that problem.
Makes sense. So despite that difficulty, what did researchers figure out over time?
Well, back in '99, Pinkowski and Dodson revisited it. They concluded it was likely a basal member of the Centrosaurian subfamily.
Basal meaning like near the root, an early offshoot?
Exactly, near the base of that particular branch of the Ceratopsia tree. Though they did add that it was also possible it was a basal member of the other main subfamily, the Chasmosaurinae, or maybe even just outside both. So still a bit uncertain.
A bit of an evolutionary enigma for a time. Did things get clearer later on?
Yes, definitely. A big step came in 2013 with a phylogenetic study by Sampson and colleagues. Their analysis strongly suggested that Avaceratops was the closest relative, the sister taxon, to another really interesting ceratopsian called Nasutoceratops.
Nasutoceratops, the one with the bull-like horn.
That's the one. This close relationship led them to formally create a new tribe within the Centrosaurinae in 2016. They called it Nasutoceratopsini, and it groups Avaceratops and Nasutoceratops together, so it found its closest family.
Ah, okay, so it's not just floating around anymore. It has a specific spot within the Centrosaurines with Nasutoceratops.
Precisely. And there are cladograms, like one from a 2017 study by Chiba and others, that visually show this. They place Avaceratops lammersi, both the original specimen and, interestingly, also that disputed skull, MOR 692, right there in the Ceratopsini. You can see how it fits with other related groups on the chart, too. It gives a much clearer picture of his evolutionary neighborhood.
That's great context. Okay, so we know what it looked like, roughly, and where it fits evolutionarily. What about its life, its paleobiology? What was it eating? What was its world like?
Well, like all ceratopsians, it was definitely a herbivore, plant eater. And back in the late Cretaceous, the plant scene was pretty different than today. You had lots of ferns, cycads, conifers. Flowering plants existed, but they weren't dominant everywhere yet.
So its diet was probably mostly that kind of tougher, non-flowering vegetation.
Seems likely, yeah. It would have used that sharp beak, characteristic of all ceratopsians, to snip off the plants. And then its teeth further back in the jaw would have sliced and processed that tough material. We can infer that from related dinosaurs.
Chomping on ferns and pine needles, maybe? What about the environment itself? You mentioned the Judith River formation. What was that like back then?
The geology, the type of rocks the fossils are found in, suggests it was a pretty wet, heavily forested environment. Think lots of rivers, streams, maybe floodplains, possibly swampy areas. Much lusher and wetter than many parts of Montana are today.
A very different world. Okay, so as we wrap up this deep dive on Avaceratops, what are the main things for people to take away?
Well, I think the discovery itself is pretty cool, that journey from scattered bones on a ranch to a named species. Then there's the whole size question, the debate sparked by that second skull, MOR 692. Is it bigger? Is it even a Avaceratops?
Right, that ongoing mystery.
And its place in the family tree, how it went from being a bit hard to place to now being seen as a key member of the Ceratopsini alongside Ceratopsians.
And I think the way it was fossilized is fascinating, too, being washed down a river. It reminds you of the messy reality of how these things are preserved.
Absolutely. And the fact that there's still debate, like about that second skull, it just highlights that science isn't static, right? It's always evolving as we find more evidence or reinterpret old evidence.
It really underscores the challenge, doesn't it? Trying to reconstruct these animals from often just fragments millions of years later.
Yeah, every new find can potentially shift our understanding.
Which makes you wonder, what else is waiting out there in the Judith River formation? What other clues about Avaceratops or other creatures might still be hidden?
That's the exciting part, isn't it? It's a constant process of discovery.
So maybe a final thought for you, the listener. Think about that immense timescale and the detective work involved in piecing together these life stories from stone. What other chapters of Earth's history are still waiting to be read?